I'd like to thank Senator Menendez and other members of the Senate subcommittee for inviting me here today to testify on matters of deforestation and climate change within the context of U.S. domestic policy and the international policy regime. I'd like to particularly thank Senator Lugar for his opening statement and including the Vulcan Project in his comments. It was an unexpected but pleasant surprise. The topic of deforestation within the broader umbrella of climate change policy intersects in complex ways with a number of scientific disciplines, including climate science, biogeochemistry, and ecological sciences. My written submission and comments today are an attempt to clarify some of these key intersections, and in doing so assist the policy process as it considers deforestation as an element in greenhouse gas mitigation strategies. Deforestation is one of many carbon fluxes or transfers between the Earth's surface and the atmosphere. After accounting for fossil fuel and cement production emissions of CO2 into the atmosphere, and taking into account the now well-quantified removal of CO2 from atmosphere by the oceans, the net exchange with the land-based biosphere remains a poorly understood portion of the overall budget. When satellite remote sensing is combined with ground-based observations and biosphere models, it is estimated that land use change, currently dominated by tropical deforestation, emits an amount of CO2 equivalent to 1/4 of that emitted by fossil fuel sources alone. This estimate, however, is not well quantified. It varies by almost 69%. Furthermore, in order to complete the atmospheric budget, the total of which is well constrained by precise atmospheric measurements, a large removal process must be at work. This removal process, which you can think of as sequestration or uptake, is understood to be occurring in the land-based biosphere and is removing almost 1/3 of the combined fossil and deforestation emissions. Originally referred to as the missing sink, which is a play on the phrase the missing link, this removal is now generally referred to as the residual flux. The reason I bring up this seemingly arcane piece of biogeochemistry is that this uptake is at work in many places, even in intact mature tropical forests, the same forest regions that are under threat from deforestation. From the atmosphere's point of view, which is the point of view central to climate change, the total net flux emerging from tropical forests, which is the sum of deforestation and atmospheric removals, is what climate science ultimately must know. The distinction between these two fluxes is therefore somewhat misleading, in that the estimated magnitude of one, deforestation for example, is actually dependent upon the estimated magnitude of the other. From the ecological perspective, however, the distinction between deforestation and residual flux uptake is crucial, as deforestation is distinct in its implications for biodiversity, regional climate, regional hydrology, and habitat. Tropical deforestation has emerged within the climate change policy discussions for a number of reinforcing reasons. It is a significant component of the overall net land atmospheric flux, and it is often the dominant source of greenhouse gas emissions for many tropical developing countries. For example, 84% of Indonesian greenhouse gas emissions in 2000 were due to deforestation. For Brazil, this number was 62%, for Malaysia, 81%. In terms of strict mitigation considerations, the deforestation flux is the first point of consideration for these and many other tropical countries. Deforestation has gained added momentum within the international negotiations due to the importance this topic holds for many other stakeholder communities, such as those focused on biodiversity, cultural concerns, and socioeconomic interests. A number of proposals have been put forth on how to structure deforestation emission reduction targets within the international regime, and pending domestic legislation reflects this structure. For example, Senate Bill 2191. Many suggest a baseline against which progress can be measured, recognize the need to create incentives for deforestation reductions, and have varying degrees of financial reward for selling credits accrued through deforestation rate reductions. The most obvious scientific question that emerges as these policy options are considered is the ability to accurately measure and monitor deforestation fluxes. Attempts have been made to quantify the level of uncertainty associated with deforestation carbon emissions. At the regional scale, such as for the Brazilian Amazon, these estimates are conservatively estimated to be on the order of 50%. Attempts to project what these uncertainties may be in a few years suggest a lowering to 16%. However, there are key caveats to these values, and these caveats could indeed increase the present and future values of uncertainty in significant ways. It is important to note that the satellite measurement component of these uncertainties is typically the most accurate. Biomass estimation, forest structure, and other ground-based elements are the most uncertain and the most difficult to improve. The measurement difficulty emerges again when considering the establishment of baselines to measure deforestation progress. Because historical data is less comprehensive and accurate than current measurements, establishing historical baselines is potentially error-prone. A series of additional difficulties emerge, such as the considerable variations in deforestation fluxes from year to year, some initiated by processes beyond human control, the difficulties associated with additionality, the continued concern over leakage, the recognition of forest degradation as a significant contributor to the total deforestation flux, and the challenges of verifying reported fluxes using independent techniques. These difficulties should not be construed as either insurmountable or a reason to delay consideration of policy options for crediting deforestation reductions. It is merely to establish what the current capabilities and knowledge are on this topic so that prudent policy choices can be made and policies structured with designed flexibility to progress as scientific knowledge improves. Whether or not current scientific knowledge is sufficient to support the current policy goals under discussion rests to a great degree on the implicit policy priorities. If the net radiative forcing of deforestation emission reduction is paramount, the current science on the net impact of deforestation on the atmosphere may be too limited and too uncertain to adequately support the aims of current proposals. If primacy is placed on tropical forest preservation, the potential co-benefit of lowered greenhouse gas emissions may not require a high level of scientific certainty. An emphasis should be placed on those aspects that assess the phenomenon of deforestation, with perhaps less emphasis on the net associated greenhouse gas emissions. Thank you very much, Mr. Chairman. That concludes my verbal testimony to this subcommittee.